Hello everyone, good morning. In this video, we'll be discussing chemical bonding and molecular structure. So this topic of chemistry is very easy to understand if we grab the basics very nicely. When we talk about bond, let's talk about what is bond. We can take bond as something that we human also practice, that we bond with someone, we are fond of somebody, we become friends with somebody. Why do we become friends? Because we like their company, we like to share our things with them, we like to know about them, we like to spend time together. So when we talk about bond is like sharing. So in chemistry also we have elements and the atoms, they interact with each other, and that interaction is called bonding. So why do we need to have friendships in our life? Because we are humans and we need to acquire happiness, and we need to have some fun in our lives. Therefore we do friendships, right? Similarly, the atoms, they try to acquire some stability in their life, they try to give some meaning to their life. So atoms, they try to make bonds for two reasons. First reason is that they try to acquire noble gas configuration. Now you may ask me, what do I mean by this? Let's talk about ourselves. We are humans. We do not have all the positive qualities in us. Suppose I can be really good at uh, let's say I can be really good at interacting with people, but I find somebody who's not that extrovert, but rather very introvert or very quiet, but he or she may have something which I find very, very attractive about them, or maybe I would like to know more about it. So that's how we kind of complete each other. When we talk about friendships and we talk about relationships in human life, we talk about that we kind of complete each other, we try to enjoy each other's company. Similarly, we try to fill the void that we have in our life. So similarly, when we talk about atoms, they try to fill their shells. So suppose if we talk about sodium has one extra electron. So when it loses it, it becomes the same configuration as the closest possible noble gas. So that's why we call it to acquire noble gas configuration. The second reason is to acquire stability. And in human life, we can say to acquire happiness. Now, how do we talk about what are the different ways of bonding? What are the different ways by which atoms combine? The first way is complete transfer of electrons. And the second one is sharing. That is sharing of electrons. If we take this in a similar example of our human lives, when we become friends with somebody, we do share our things, maybe our belongings, our stationery, our notebooks, our pens, right? Or we either completely give them our ones, and we can share it, like we can have a common book, and once one friend reads and the second time the other person reads. So similar things happens in case of atoms also. They form bonds by either two ways, by complete transfer of electrons or by sharing. When we talk about complete transfer of electrons, what type of bonding we are talking about? We are talking about ionic bonding. And when we talk about sharing of electrons, we are talking about covalent bonding. Right, guys? Now, when we understand, we say that the bond is being formed. So you must be knowing that we have electron dot structure. Like for hydrogen, hydrogen has one electron. Helium has two electrons. Lithium has three electrons, but the configuration is 2.1. So in outermost, it has only one electron. Similarly, in case of sodium, the atomic number is 11. So the configuration is 2.8.1. So the outermost shell has 1 electron. So sodium has 1 extra electron. So let's talk about the bond formation. We said what are the Lewis structure? The symbols in which valence shell electrons are represented by dots, ignoring the inner shell electrons, are called Lewis symbols. So if I talk about draw the Lewis symbol of magnesium. So what is the atomic number of magnesium? 12. So the electronic configuration is this in K, L, M. So in outermost, how many electrons are there? 2 electrons. Right, guys? So you can write down in your notebook, magnesium has 2 electrons. So this is the Lewis structure for magnesium. Now you may ask, okay, ma'am, can we write magnesium like this? Of course. Can we write it like this? It's your choice where you want to show the outermost 2 electrons. Wherever you want to show them, you can show, but you have to show them in a pair. Why? Because when we talk about electrons, we happen to call them electron pair. So at the very beginning of the class, I'm telling you, when the electrons are there, try to write them in the form of pair. Do not write like this. Suppose if I say write about magnesium and you say, ma'am, I'm writing magnesium like this. Don't write like this. Generally, there can be certain cases when we are drawing the structures and the two different electrons go and been shared by other atoms. But most of the time when the electron pair is called, so the two electrons are drawn together. What is the significance of Lewis symbol? The number of electrons in the valency shell is shown, and then we can predict the valency of the atom or the element. Lewis pictured the atom in terms of positively charged kernel, the nucleus plus the inner electrons, and the outer shell that could accommodate a maximum of 8 electrons. So maximum, how many electrons should be there? 8 electrons. If 8 electrons are there, so we can say the shell is completed. Lewis found that octet of electrons represents a particularly stable electronic arrangement. To achieve octet of electron, atom can combine either by transfer of valence electrons from one atom to another, by gaining or losing, or by sharing of valence electrons. This is called octet rule. So 8 word is called oct, so this is called octet rule. So whenever there is a bond formation, according to Cossel-Lewis concept, we must have the total 8 electrons in order to acquire the stability. But exceptions will be there. Yeah, in chemistry there will be exceptions. I'll be talking about exceptions too. So let's draw the, let's say if I want to ask you, draw the Lewis structure for chlorine. So what is the atomic number of chlorine, guys? 17. What is the electronic configuration? 2.8.7, right? How many electrons in the outermost shell? 7. So how can we draw 7 electrons? We can draw dots, we can draw cross, anything that you feel like. So the 1 electron is here, you can see this 1 electron is alone, and there are 3 electron pairs and there is 1 odd electron. So let's talk about types of bonds. So the bond can be formed between the atoms of same molecule or between different molecules. So we can divide them in 2 parts. Between atoms of same molecule. Or between different molecules. I'll talk about it. What do I mean by this? I'll talk about it. So between atoms of the same molecule, this can be further divided into 4 categories. The first category is ionic bond. In your junior classes, you must have heard of it. Don't worry, I'll discuss all the types of bonding. Then the covalent bond, coordinate bond, and the fourth one is metallic bond. So the speciality of this type of bonding is these four types of bonding is happening between the atoms of the same molecule. We'll be talking about one type of molecule and between the atoms of them. Now between different molecules, so we can have two types of bonding here. First is hydrogen bonding and other is van der Waals force of attraction. I hope thoda bahut you must have heard about hydrogen bonding, van der Waals forces, right? So we'll like one by one we'll be talking about each and every type of the bonding. So the difference, the most important point is if this is happening between the atoms of the same molecule, we have these four types: ionic, covalent, coordinate, and metallic. And if they are happening between different molecules, hydrogen bonding and van der Waals forces. We can take one more example. Suppose when you are studying in your class and you have a group, okay? And suppose in your group you have 6 people. So what you can do, you can either give your, like suppose you have an extra pen, you give it to one of your friends. It's a type of ionic bonding. So within the same class, your friends, right? Between the atoms of the same molecule means between friends or the students of the same classroom. Now, the other example that you can understand here is between different molecules, you can be friend with a student from the different class. This can also be the case कि भाई 11th A वाले बच्चे का फ्रेंड 11th C में पढ़ता हो या 11th C वाला D वाले के साथ B वाला फ्रेंड्स तो हो ही सकते हैं. अब 11th A के अंदर कितने फ्रेंड्स हैं, that is between atoms of the same molecule. But you are friends with other section also, then between different molecule. By molecule I mean classroom, and atom by atoms I mean students. So in that way you can understand. So one more important thing, since you spend more time in your class, right? So your friendships with the person or with your friend who you're spending more time with will be, the intensity or will be the bonding will be very strong. But when the kind of friend or acquaintance you have in different sections will be small, like will be weaker. So we can say the between different molecules that bond is not that strong, but between the same molecule the bonds are strong. So if we talk about the relative strength of the bonding, so yeah, between the atoms of the same molecule the bonding is stronger, and between different molecules this is stronger. This is comparatively weaker. Okay guys, let's now talk about ionic bonding. Ionic bonding is also called electrovalent bonding. Why such name? Because in this, the electrons in the valency shells are accepted or being transferred. So I can give example of, let's say, hydrogen chloride. HCl acid, we have heard. So hydrogen has one electron, right guys? Just like a few minutes ago, we have drawn the Lewis structure. Hydrogen was shown with one dot. And chlorine we had shown like this. In your notebook, write down like this. Okay. Now the octet rule says, in order to acquire the stability, the shell should be completed, and the shell should be completed by 8 electrons. In case of hydrogen, since hydrogen is a small atom, so we can consider either 2 or 8. So in case of hydrogen, the full valency is considered by 2 electrons, and in other atoms it is considered by 8 electrons. So what will happen? We can say this one electron is transferred from here to here. So what will happen? When something is given out, we have, in our life also, when we say give something to the society, give something to this world. So when we give away something, be it some money, education, or it could be anything which you can give out to the world, then we feel very positive about it. So when something is being given out, we can say it has become positive. So H has become plus because it has donated one electron to Cl, so it has become 1 plus. And since Cl has accepted one electron, and positive and negative, they attract each other. So we can say this is this bond, electrovalent bond. This is ionic bond, complete transfer of electron. So this is H plus ion, this is Cl minus ion, and they are attracted to each other by positive attracts negative. So there's an attraction because there is a formation of ion. Positive ion is called cation, negative anion is called anions. Ion word is common in both. So therefore we call them ionic bond. We can take one more example. Let's say NaCl. Salt, you must have heard of it. In our kitchen also we use it. Sodium, let's draw the electron dot structure of sodium and then chlorine. You know the electron number, the atomic number of sodium is 11, 2.8.1, one extra electron. For chlorine it is 17, 2.8.7, and then it has one electron short of 8. So what can happen? There can be electron transfer. So when this happens, sodium becomes 1 positive. And since Cl has accepted 1 electron, it becomes negative. Positive attracts negative, right guys? So this type of attraction is called bonds. So ionic bond is not just that line that I'm drawing. It's more like attraction. But to realize it on sheet of paper, we draw it with this line. Okay? So do not consider कि Cl और Na के बीच में एक line बन गई तो उनका bond बन गया. Bond को दिखाने के लिए we have shown it with the line or something. But actually it's just a force of attraction. What is bond? A force of attraction. And since the force of attraction is between the positively charged entity and the negatively charged entity, charges are involved, so this force is strong. So ionic bond is strong. In your notebooks, please write this type of structure for KCl. Similarly, in case of K, the only difference will come of what will be the difference? The atomic number will change, but similarly, the potassium will also have 1 electron in the outermost shell. Let's draw the structure for magnesium fluoride. So magnesium, atomic number 12, electronic configuration 2.2. So the total electrons in the outermost is 2. In case of fluorine, what is the atomic number? 9, 2.7. So we can draw the structure as like this. So magnesium has 2 electrons and one fluorine is 1 electron short. So suppose you have total 2 pens, and then how many friends you can help in your exam? 2 friends. If you have 2 extra pens, you can give it to 2 people in your exam hall. Similarly, what will happen? This magnesium will combine with 2 fluorines. Why? Because magnesium has 2 electrons in its outermost shell, 2 extra electrons. So 1 electron will be given to this fluorine and the other electron will be given to the other fluorine. So one magnesium is combining with 2 fluorine atoms. Hence, we can draw the structure like this. Magnesium combines with fluorine and chlorine. This is magnesium ion. Since it has lost 2 electrons, so it will acquire 2 plus charge. Fluorine has accepted 1 electron, so 1 charge. You may also ask, ma'am, why are you drawing the ions in the spherical shape? Because when we talk about attraction, obviously there will not be a complete spherical atom, but we assume it to be spherical. So therefore I have shown it to be like this. Magnesium like this, and 2 fluorines are attached to 1 magnesium atom. When a bond is formed by complete transference of electron from one atom to another, so as to complete their outermost orbit by acquiring 8 electrons in their valency shell, is called ionic bond. Ionic bond is formed between metals and non-metals. It is the force that binds cation and anion. The magnitude of charge is equal to the number of electrons gained or lost. Just now I have told you, since magnesium has lost 2 electrons, therefore there is 2 plus charge on magnesium. Fluorine has accepted 1 electron, there is 1 negative charge. So the number of electrons lost or gained is equal to the magnitude of charge acquired by the respective ion. Okay. So I have one exercise for you. If you're done with this, we can do that exercise. Exercise says, consider the hypothetical elements x, y, z. X has structure this, y has structure this, and z has structure this. To which group in the periodic table these belong? Look at the Lewis structure and tell me to which group these three belong to. Think about it. So we can see in case of X, we have 6 electrons in the outermost shell. If there is 6 electrons, so they can belong to which group? Tell me. Give any example of any element that you can think of जिसके पास 6 electron हो outermost shell में. सोचो. Let's memorize the series: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, right? 2.6. So oxygen belongs to which group? Think about it. Exactly, 16th group. Very good. And Y belongs to, because there are 7 outermost electron, 17th group, just like halogen, just like fluorine, chlorine, bromine, iodine, we call them halogens. And Z, it has 4 in the outermost, looks just like carbon, right? If you're not able to find out how, just memorize the series: hydrogen, helium, lithium, beryllium, boron, carbon. So carbon is 6, atomic number 2.4. So carbon belongs to which group, beta? Exactly, 14th group. We can say this belongs to 14th group. So by looking at the Lewis structure, we can determine our element belongs to which of the group in the periodic table. Okay. Now, tell me one more exercise. The second question says, write the electron dot structure for simplest compound of each with hydrogen. Compound with hydrogen. Make, आपको क्या करना है, इन तीनों एलिमेंट्स का, ये तीनों एटम्स का हाइड्रोजन के साथ कंपाउंड बनाओ. तो यू नो हाइड्रोजन हैज 1 इलेक्ट्रॉन. अब हमें 8 इलेक्ट्रॉन्स पूरे करने हैं. So how we can do that? The first one, this first X has 6 electrons. So in order to acquire 8 electrons, how many hydrogen it will need? 2, because one hydrogen is giving 1 electron and this X is having 6 electron total. So in order to acquire 8 electrons, it may be needing 2 electrons extra. So it will require 2 hydrogens. So what will be the formula? Formula will be H2X. Yes or no? Think about it. Right? Similarly, Y is only 1 electron short, right? Y has 7 electrons and in order to acquire octet, it just requires 1. So in case of this, what will be the formula? 1 hydrogen, 1 Y. So this HY. In case of Z, there are 4 electrons. In order to acquire 8 electrons, how many electrons more are needed? 4. 1 hydrogen provides 1 electron. So how many more hydrogen? Yes or no? Right? You can write like this or write like this. Your call, which way you want to write. Okay. Similar question. The third part is write electron dot formulae for the ions formed when X and Y reacts with sodium. When X reacts with sodium, sodium has 1 electron extra. X is only 2 electrons short. So how many electrons can it accept? It can take 2 sodium. So they can be X. In case of Y, there are 7 electrons here. Sodium has 1 electron extra. Sodium this. Right, guys? NaY into X. Think about it. If you are not able to understand, so what will be the anion here? X2 minus, and here will be Y minus.